Hello class, this is a video tutorial on polynomials. In this video, we'll be looking at the remainder theorem. The remainder theorem states that if we have some polynomial p of x and it's divided by a divisor of the form x minus a, the remainder is always going to be the function value of the value of a. This can be seen very quickly using synthetic long division. You can pause the video and try and do a synthetic long division yourself. Now remember, of the form x minus a, in this case the value of a is 2. Taking the coefficients of our dividend, 3x to the power of 4, 0 x cubed, negative 2x squared, 5x, and 1. Ignoring the first and multiplying, adding, multiplying, multiplying, adding, multiplying, and adding. From here, always remember that the result is always 1 degree less than the original dividend, plus 6x squared, 10x plus 25, plus 51 over x minus 2. So that is our remainder, but we can very quickly find just the remainder. Now remember, this shows us the entire quotient and remainder. If we only need the remainder, we can simply just go p of 2, and I can show you using the calculator. So 3 to the power of 2 to the power of 4, I'm substituting it here, minus 2 to the power of 2 squared plus 5 times 2 plus 1, 51. Notice how the function value of a is the same as the remainder of the division. So let's quickly do that again. You can pause it and give it a go yourself. Remember, we need to figure out what the value of a is. It's x minus 4, because that would make it a positive 4 in that bracket. So our value here is negative 4. Taking the coefficients 5, negative 7, 1, and 1. Ignoring the first and multiplying. 5 times negative 4, negative 20. Adding the 2. Negative times negative 4, 108. Adding the 2. Negative 4 times 109, negative 436, adding the 2, and remember that this will always be 1 degree less than our original dividend, x squared, x whole number divided by x plus 4. So if we were to substitute p of negative 4 into this function, you'll find that it will actually equal 435. So let's take a look here. 5 times negative 4 cubed minus 7 times negative 4 squared minus 4 plus 1. Negative 435. Now, from this, it's a very straightforward idea, but from this, we can use this to solve for missing coefficients. So let's go straight into a few of these examples here. You can pause the video and give this a go, but here we go. So now it's saying, let's solve for the value of p given the dividend the divisor, and we know the remainder to be 4 from this division. Since we know that the remainder is 4 in this division, that means when we substitute -3 into the function value, we know that the result is going to be 4. So substituting this in, 2 times -3 to the power of 4 minus p times -3 plus 5. And we know this to be equal to 5. Evaluating this in my calculator, 2 times -3 to the power of 4 is 162. Negative times negative plus 3p plus 5, my apologies, should be equal to 4. Adding these two together, solving for p as we normally would, a linear equation, -163, p is equal to -163 over 3, sorry. Okay, and there we have it. Now there's another way which we could do it, but I'll show you that in another video. It's very simple enough using this method, so let's just continue doing this. So in this, we know that x minus a is going to be 2. So we know that when we substitute the value of 2 into this equation, we get a result of 22. So it's going to be 2 cubed is 8 minus 2 squared is 4 outside of k minus 1. 5 times 2 is 10k plus 4, and we know this to be equal to 22. Collecting like terms, actually let's expand this first here. This will be -4k plus 4 plus 10k plus, adding these two together gives us 12. Adding this a little bit more, the 2k's give me 6k plus 16. Subtracting 16, 6k is equal to 22. Take away 16 is 6. K is equal to 1. I just realized we said solve for p, but we have k here. Regardless of what the letters we're using, the idea remains the same. So that is remainder theorem. Restating it again, when we have a divisor of the form x minus a, the remainder is always going to be the function value of a. So, hope to see you in the next video. Best of luck.